Hello students, let's begin another important topic, that is interhalogen compounds. So what are interhalogen compounds? They are compounds formed by two different halogens. So different halogens react together to form interhalogen compounds. They are of the type XX dash, XX3 dash, XX5 dash, XX7 dash. So these are the type of interhalogen compounds where X is a larger size halogen with less electronegativity and X dash is a smaller size halogen with more electronegativity. So let's see some examples: CLF, CLF3, BRF5, IF7. So CLF, considering CLF, so X is Cl and X dash is F here, and Cl is a larger size halogen which is larger than F, and fluorine is smaller than Cl. And also the electronegativity, X should be having less electronegativity. So Cl is having less electronegativity and F is having more electronegativity. So this is the type of different interhalogen compounds. So CLF, CLF3, BRF5, IF7 are examples of these types of interhalogen compounds. Now let's see the preparation. So preparation is actually the direct combination. So direct combination of different halogens. So by direct combination of different halogens, we can prepare interhalogen compounds. So these equations are important. So Cl2 plus F2 and I2 plus Cl2. Here this reactants are to be taken in equal volume. So Cl2 and F2 in equal volume and I2 and Cl2 in equal volume. We will get the product as ClF. Here it is ICl. Then the next case, Cl2, F2, I2, Cl2. Here F2 is to be taken in excess, Cl2 is also to be taken in excess. So in that case we will get ClF3 and ICl3. Then in this case here it is diluted with the water, and here F2 in excess. That is a condition. Here we will get BRF3. Here it is BRF5. So these are the products. So these equations are important. You need to balance all these equations. So this is about preparation. So in the case of interhalogen compounds, they are all covalent in nature. So all interhalogen compounds are covalent in nature and they are diamagnetic also. So interhalogen compounds are covalent in nature, and also they are diamagnetic. They are diamagnetic in nature. So since they are covalent in nature, we can reduce the shape of different interhalogen compounds using VSEPR theory. So using VSEPR theory, we can reduce the shape of different molecules like BRF3, BRF5 and ICl7. So, or IF7, not ICl7, it is IF7. So these are the three important compounds. Here we need to deduce the shape. That is an important question. So deduce the shape of these interhalogen compounds. So in the case of BRF3, so we need to find out the number of bond pairs and lone pairs. For that it will be half into, so outer shell electrons in Br, that is 7, plus 3 atoms are attached with bromine. So it will be half into 7 plus 3, that is 5. So it is having since three atoms are attached, there will be three bond pairs and the rest two will be lone pairs. So three bond pairs and two lone pairs. So the shape of the molecule will be Br. So this will be the shape. So this is actually bent T shape. So in order to minimize the repulsion between lone pair and lone pair and bond pair, it will be the shape of bent T. So that is the shape. So since it is having bond pair and lone pair, we will not get a trigonal bipyramidal shape. So actually, if it is 5, it will be trigonal bipyramidal shape. That is sp3d will be the hybridization. So sp3d will be the hybridization, and we are expecting a trigonal bipyramidal shape. But due to the presence of these lone pairs, uh, the geometry will be bent T shape. So we need to write bent T shape, and this will be the structure of BrF3. Now let us see next compound, that is BrF5. So BrF5, it is again half into 7 plus 5. So it will be 6. So 5 atoms are attached. So it will be 5 bond pairs and 1 lone pair. So the shape is here is the lone pair. So this is square pyramidal. So BrF5 is having square pyramidal shape. Now let us see next compound, that is IF7. IF7, here it is half into 7 plus 7. It will be 7 and 7 atoms are attached, so it will be 7 bond pairs and 0 lone pairs. No lone pairs are there, so we can write 7 bond pairs, and we can draw the shape as it will be like this. So it is a pentagonal bipyramidal structure. So the shape is pentagonal bipyramidal. So this is the shape of IF7. So we can deduce the shape using VSEPR theory of different interhalogen compounds. So these three are very important. Now let us see the uses of interhalogen compounds. So among interhalogen compounds, BRF3 and CLF3, they are used as fluorinating agents, and they are used for the production of UF6. So UF6 is used as a nuclear fuel. So BRF3 and CLF3, they are used as fluorinating agent, and these are again used for the production of UF6, that is a nuclear fuel. So we can expect one question from this part, another question from this part, that is ICl is weaker than I2. Why? So this I2 is formed by the same halogen, here different halogen. So this is an interhalogen compound. So in the case of interhalogen compound ICl, the bond is weaker. The bond is weaker. In the case of I2, so here the bond is stronger. So ICl is weaker than, or ICl is, since it is weaker, it is, you can write it is reactive. It is reactive. ICl is more reactive. ICl is more reactive than I2. So ICl is more reactive than I2 since the bond is weaker. So in the case of interhalogen compounds, the bond is weaker. In the case of I2, the bond is stronger. So the electronegativity difference is there in the case of interhalogen compounds. There will be more polarizing nature of the bond. So the bond is weaker and it will be more reactive. In the case of I2, the bond is stronger and it is less reactive. So ICl is more reactive than I2. So that is one question. And here we need to remember F2. In the case of F2, which is more reactive. But F2 is more reactive. So F2, in the case of fluorine, we have already studied there is interelectronic repulsion. So it is very easy to break the bond. So this is more reactive. So in the case of fluorine, it is more reactive. But in the case of iodine, the bond is stronger. So in this case, the bond is weaker. So it is an exception. Fluorine is more reactive. But in the case of iodine, the bond is stronger. So it is less reactive. In the case of an interhalogen compound, the bond is weaker and that is more reactive. So this is about interhalogen compounds.